write as well as data, and then again we have declared our array left child as well as right child, and we followed this particular you're able to see paint, right?
Yes.
We are following this tree. So as per this tree, we have something like 1, 3, 5, 7. So here A is pointing to 1, which is B, and then for right child it is pointing to 2, which is C. Similarly, B is pointing to 3 and 4. Similarly, C, 5 and 6, and thereafter D doesn't have any child. That's why we have -1, -1. Now, in this, what we did is, I think we finished this program. We didn't execute it or we didn't write it.
I think written it off till that each statement.
Okay, we will just check it out. Okay, so we are taking one pointer variable for type struct node, which is root, and thereafter we are using a function called build tree.
Okay.
And we are passing an element 0. Why? Because our tree starts with 0 index. So that's why we are taking it like 0. So here, when coming to build tree function, what we are doing is, in build tree, we are using again one more pointer variable which is of type struct node, and we are initializing it with null. Now, here your index starts with 0. So that's why we are just comparing it with -1. So if it is not equal to -1, then perform the next operation. So performing next operation is assigning memory for that particular node, which is of again struct node. That means again for this struct node right, left and data, memory will be assigned. And thereafter we are seeing that temp left. Now what does left should have? Left should have, again what we are doing is we are calling build tree function again. This is recursive function because the function is calling itself. So that's why we are calling it as recursive function. We are calling our build tree with an index, left child index, which means we are actually passing build tree of 1. Okay, actually build tree of 0, build tree of LC0. LC0 is nothing but 1.
Yeah.
Right, LC0 is 1. So once it's called that, again it will just take the value and it will just check whether it is index is -1 or not. We are passing an index value of 0. So 0 is not equal to -1. That's why again it will assign the memory.
Okay.
Okay. Now again it will check that. I'll just now the first one was done. So now it will go to second B. Okay. When it go to B, again it will check that again build tree, it is passing an index value. Got it?
Yes.
Once it is called build tree. So index will be 1. After that again it is assigning some memory which becomes B.
Okay.
Okay. And then again we are checking that index 1. Now the value of index was index is 0. So you are passing an index value of 0 here, and thereafter you are just checking whether it is allocated or not. Now when this is not -1, that means again it has a child. Again it will go to build tree.
Yeah.
Okay. Then again it will allocate some amount of memory.
Yeah.
Okay. Till it comes till D.
So, yeah.
Okay. Once it comes to D index, it will just pass the data to it. Okay.
So,
We are building a tree. So here when we give a value of 0, we are passing a value of 0. 0 is not equal to 1. That's why we are calling this node again.
okay.
Because we want to have after a first, as we are building tree, it will not just store A first. It will go till D. Is it clear?
Okay. So when it is comes to what the -1, when the condition is
-1.
condition is false, so it will return the temp, right? So
Right.
to which function it will call, which called it on last, the
No.
latest function which
Okay. See, first it will be at this particular build tree only.
yes,
Okay.
yeah,
When you go to this function again, it will execute and it will allocate memory for B.
yes, yeah, yes,
Okay. Then here again what will happen? Again you are calling an index.
yeah,
Okay. So here again it will come to temp and now the value will be for D.
yes,
Okay. After
yeah,
D at that time what will happen? Index is equal to -1 because D doesn't have a child.
yes.
Okay.
Condition
Then
true.
it will directly come to return function.
Return,
Now
yes,
return temp, the value was D because we have allocated memory for D.
yes, yeah,
Okay. So once it returns, then again it is written into B.
okay,
Okay. So already we have executed this particular function for B.
yes, yes,
Then it will go to data and it will execute this.
okay, yeah, fine,
And then it will go to write function. In write again it will check and again it will allocate the memory.
okay, fine, yeah,
Right? Is it
yeah,
clear?
yes, yes,
Right. Now, this was for building because this is the basic function to build. Whatever programs we are going to write, we are using the same function.
okay,
Okay, and then we have in order, as we discussed, we have three things. So in order, again we are passing a pointer which is pointing to your struct node, and we will see that whether it is null or not. Okay, now if it is not null, then it will go to first left, then your data, and then your right. Okay, now here, now here if we say, okay, this is the function now. Now, once you go to in order function, it will first go to left.
okay,
Okay, which is nothing but B.
yeah,
Right. Then again it is calling the same function in order and it is passing the value of B.
yeah,
B is not null.
yeah,
Right. Then this condition fails. It will come back.
no,
Okay. Then it will print the data. Till again it will call the root left, which is nothing but again it will be pointing to D, and at D when it is equal to null, at that time it will return.
okay,
Okay. First you are passing your root, which is A. Again you are calling this A, which is not equal to null. That's why it will go to B. B is not equal to null. It will come to D.
okay,
Right.
yes,
So at D it will pass the data.
okay, yeah,
Once it comes there, again it will go to right.
okay,
The same thing which we used here, we are using the same thing, but here we are only using for printing. That's it. Here we were storing the data. Here we are printing the data. Other than that, there is no difference between that and this. We are simply traversing. First we are going to D. We are printing the data. Again we are coming back to B.
okay,
From B again we are coming to E.
okay.
Okay. So this is clear. If this is clear,
Yes.
we will go to other function. Okay. So this is also clear, right? If we are using three arrays.
Yeah,
Okay. Now in place of this particular three arrays, we can use only one array. and it will be like this. That means simply we are after I, we are writing these particular elements.
Okay.
Okay. Now how to access that element? We know that your left child will always have odd numbers.
Yes.
And your right child always have even numbers.
Yeah.
Right? So here we are using the formula for that, and that is 2 into index or value plus 1. So when index value is 0, at that time the 2 into 0 plus 1, it becomes your first element. Similarly, when it increments, the size of your index increases. Index become 1, 2 into 1 plus 1, 3.
Okay.
Similarly, when it becomes 2, 2 into 2, 4, 4 plus 1, 5. So you will get elements like 1, 3, 5, 7 and so on. Similarly, if we write it like 2 into n plus 2, it becomes odd number. 2, 4, 6, 8, 10.
Okay.
Okay. So by using this we can implement this. So same, we are using some structure node, and thereafter what we are doing, after this now, the function for build tree will change. Rest of it, everything will be same.
Okay.
Okay. Only the build tree function will change. Now here what we are doing is we are simply checking, we are passing 0. After passing 0, here what we are doing is we are initializing this with null, and we are checking that array of 0 is not equal to null character. Now if we see our array of 0 is A.
Yeah.
Right. So if it is not equal to null character, then execute this. It is not equal to null character because this is equal to A. So it will allocate some amount of memory.
Okay.
And then your left child is nothing but you will call this build tree with index number 2 into index plus 1. So this is 1. So build tree, here you are calling this build tree with index 1.
Okay.
So again here array of 1. Array of 1 is not equal to null character. Again allocate some amount of memory for it.
Yeah.
So you will do this till you reach null character.
Okay.
Okay. Similarly, after assigning data, you will be executing this right.
No.
So this is for your, if you are using only, till now we have implemented tree using arrays. Now we will implement it using your linked list.
Okay.
Now, if we want to, here you have one more concept, and that concept is, just remember this, or else I'll just take a screenshot of it. 1 second. Now, here we have one more thing called binary search tree. Okay, BST, which is binary search tree. Now, what is this binary search tree is? It will have only left child. It will not have right child.
Okay.
Okay. Oh, no. I'm so sorry. I just got confused. You will have elements, but what you will have is, okay, sorry. That was different tree. If it is left child only, then we call that tree as something else. I got confused with that, I think. I'll tell you what it is called. So that particular tree, if you have, that is called strictly binary tree. Already we discussed it morning, I think. Strictly binary tree, it will have only left child and no right child.
Yeah.
Okay. Now here we have one is a tree called BST, which is binary search tree. Now in this, what will happen is, if you have some element, then it will compare the second element, whether that element is less than or greater than that particular number.
Okay.
Okay. So if it is greater than or less than, depending on that, it will assign whether it is left child or right child.
Yeah.
Okay. Now if we see, suppose we have something like, first we will have one variable now. If we say this one, now suppose here for example, if we have a tree called, we are taking some value called 20. I'll just 1 second. I'll download a image. Binary search tree example. If you are able to see this image, Google Chrome.
Yes. Yeah.
Now, here if we see any example, if we see, so here, is it visible?
Yes.
Now, here we have root as 40.
Okay.
Okay. Now, when you enter the next element, it will check that whether the next element is less than or greater than 40. Okay. So when it is 30, if it is less than 40, it will just enter that element in left child.
Okay.
If it is greater than 40, it will insert that child in right child.
Okay.
Okay. Now next you are entering 25. So here again it will check that whether 25 is greater than or less than the other number. So if it is less than, then it will be like 25 and 35 you are entering. So whether 25 is greater or 30 is greater than. Now if 25 is greater than or not equal to 30. If it is less than 30, it will be as left child. If it is greater than 30, it will be right child.
No.
Okay. So whatever left child is always less than the right child, and that will be compared to the parent node.
Oh.
Okay. Because 25 and 35 parent node is actually 30. Right?
No. Yeah.
So 30 is the parent node for 25 and 35. When you enter the element in that particular node, it will check the value of that node, that whether it is greater than or less than. If it is less than, left. If it is greater than, more. Right.
Oh.
Right.
Right.
Okay. This particular thing you call it as binary search tree. Okay.
Yeah.
So in this, if we implement one program, so the only thing will be you will have to check whether it is greater than or less than. That's it. Now I am entering some elements. Okay. Now I am entering some elements. So here I am taking one struct node and then I am initializing it with null and then I am inserting the values 1, 2, 3, 4, 5. Okay, and then we are printing it in order, pre-order as well as post-order. We are implementing all the three in this program. So here, if we see insert function will be different. Why? Because we are writing it for whether it is greater BST. BST is just a second. Just a second. Okay, so this is our insert function now. Now, in this insert function, we are passing a pointer as well as one number, right? So after this, we are saying that we are checking whether it is null or not. If the tree is equal to null, then first insert the first element.
No.
Okay, this is only for first element. Why?
No.
Because starting tree is empty. So here again we are allocating some amount of memory, and then what we are doing is we are saying that this particular node left is null. Why? Because this is root node.
No.
Okay, at starting we are saying, so this is equal to null and your data is nothing but your number and right side is equal to null.
No.
Okay, so this is for first node because till now we have not created the other node, that's why the left and right side is null. Now,
Okay.
after that, your queue is not null anymore for second element.
Yes.
It will directly come to else. Now we will
Okay.
see that whatever number you have entered, here we have entered 2. Whether
Okay.
this 2 is less than this particular data pointed.
Okay.
So right now your data is pointing to 1. Your pointer Q is pointing to your data which is 1.
Okay.
Okay, so it will compare whether your number is less than this 1 or not.
Okay.
So here the number is 2. 2 is less than 1. The condition fails.
Yeah.
So what it will do, it will insert it at this particular location which is right.
Okay.
So now for insert what we will do, we will pass this again, the right child as well as number we will pass. So then now your pointer will now point again and it will see that we are passing your number which is 2 as well as right side of your pointer. Now again your pointer is equal to null. Now the second node which we created, we have to create a second node now. Okay. So here it is equal to null. Second, which is nothing but C. Right side we have C element, right?
Yeah.
Right side we have an element C. Here it is C, right side it is C, right? So when, as it is greater than 1, that will be inserted right side. So here we are passing the address of this particular right as well as number to your insert function again. We are calling a recursive function, and then again this pointer is pointing to null because C is null. We don't have any node yet. So as there is this is equal to null, we are allocating some amount of memory, and then we are saying that the node which we created just now, which is nothing but C, which is this C node, again we have not created F and G node, so it should point to null. That's why we are allocating this null, and then we are giving a number which is nothing but 2.
No.
And then we are returning. We are returning to this particular condition only, which is this else. Right? Here, for the first time, we are checking whether it is null or not for root 1. Okay, once you use root, then you don't have anything. After inserting A, you will have to insert B.
Yes.
Right? So
Yes.
for inserting B, again we are calling it from our main function that insert 2.
Okay.
When you are inserting this 2, it will see that whether it is your right child or left child. 2, if you say 1 is less than 2 or 1 is greater than 2. There you have to insert this.
No.
Okay, so as this 2 is greater than 1, it has to be inserted in right child.
Yes.
Okay, so when you say this is the right child, you will have to find out, you will have to write the condition for that. So if we forget this, directly it will come here. Okay, number is 2. 2 is less than whatever your pointer is pointing to. So my pointer is pointing to 1.
Yeah.
Okay, so whether that number is less than 1, yes. 1 is not less than 1, 2 is not less than 1. So this if condition fails. Then it will come to else condition, and here we are saying that pass this particular address and number to insert again.
Okay.
So we are calling this function again. Now, here when you are writing this, you are just pointing to this particular pointer Q right. Okay. So this is not your root node now. This is not no more root node. You are pointing to this particular next node. So here this next node is null. C is not present actually. We have to allocate that amount of memory now because C is not present. We are simply checking that the next data which has to be inserted from root node in left side or right side. We just got to know that yes, we have to insert it in right side.
Okay.
Okay. So once you say that it has to be inserted right side, you are passing an address to it. So till now you have not allocated memory. So as you have not allocated memory, you don't have anything in it. Everything is null.
Okay.
So once you see that here it is null, you are allocating some amount of memory. Now this memory is allocated and you are naming it as C.
Okay.
So when you say this again, C, we are not having any child yet for C. So that's why again that will also be initialized with null.
Okay.
But a value will be given to C. That's why we are writing pointer Q is equal to pointer Q which is pointing to data is equal to number. So this number 2 is passed to this C.
Okay.
Okay. Similarly, again what we are doing is we are repeating the same function again. When you are saying 3, where this 3 has to be inserted again. Like that, we are continuously checking this function again and again. And if it is left, again pass this left address as well as number to this struct node. So you are passing the address, there is nothing there. So it will be null, you will be allocating memory, and then again you will be initializing it with null.
Okay.
Is it clear?
Yeah.
So this is the basic thing you will have in here. This is the way you will be inserting it if it is BST. Okay.
No.
Next, you will have some order. We discussed we will have some in order, post order. In order, then you will have something like, I have just to copy and paste it. So pre-order, and this is post order. Okay. So if we say pre-order, here you will have in order. If it is not null, first check for left data right. Travels from left to right.
No.
Left root and then right. If we say pre-order, you will first check for root and then left and then right.
Okay.
And if it is post order, first you will check for left and then you will check for right and then you will check for root.
No.
Okay. Functions will be same. Again and again you are calling it. That's it.
No.
Okay. 1 second. I have just written some that should not be there. Leave it later. So this is how you are traversing it. Now, if we want to delete some data, okay, so here I have written it here. Here I have to write one more function. I'll write that, but before that I'll just say you delete function. If we want to delete some nodes, okay, so there will be something like if we are using some binary, basic binary tree, then you may have different options, okay. So how that option has to be used. Now suppose when you want to delete a particular node, that might not be present at all. You are entering some data, but that might not be there, okay. And this, you may have something like if you want to delete a node, there might be no child for that node. That means it might be leaf.
Yes.
Yes. Now, if you want to delete a node, it can have only one child.
Yeah.
If you want to delete a node which will have two childs.
Yes.
Right?
Yes.
No node at all. Node without child. Node with one child. Node with two childs.
Okay.
It's audible, right?
Hello.
Okay. So we will have to write for. Is it audible?
Yes. Yes.
So that means we will have to write 4 conditions for this. But before that, here we will have some conditions there. Like if you will have some in that cases. Now, if there is no node and if you have to delete a node with no children, there is no problem.
Okay.
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 That means like if you want to delete something like H or I here, there is no problem.
No.
You can delete it easily.
No.
Okay. Now, if I have only one child, or I'll write here one more child. Now, I have one more child here, which is for J. Now, what happens if we want to delete this particular G? Okay.
Okay.
Now, I want to delete a node G, which has only one child,
Okay.
which is J. Okay. Now, when you want to delete this particular G, then you will have to pass the address of J to the C. Now, J will take the place of G.
Okay.
Okay. If you are deleting only one, that means simply what you can say is if G is parent and C is grandfather and J is son, then yeah, after G is deleted, your grandfather will point to son.
No.
Okay, this is one case when you want to delete node with one child.
No.
Okay, now if you want to, now this is like, yeah. Now, if you want to delete a node with two childs,
Okay.
then at that time, what happens is, if you want to, here, now in place of G, I want to delete C. Okay. C does have two childs. One is F and other is G. Right?
Yeah.
We have two childs. One is F and the other is G, and I want to delete this C. At this time, it will check the successor. Okay, whether F has child or G has child. So here
Okay.
in this case, G has a child J.
Yeah.
So in place of this C, now J will come. Hello? In this
Hello.
case here, J will be, hello? Is it clear? I'm a bit audible and clear.
No, I think
In
some
place of now,
network
when
issue.
you want,
No.
okay.
Voice is
Actually, I
breaking.
don't have power again, but I have. So there might be a network issue from my side. Oh no, my battery is also. Again, here if you want to delete this particular node, then it will check for the successors. Okay.
No.
Of F and G. So here
I think
G
your
has a child.
drawing board is not visible. Hello.
I've been connected to mobile network actually.
Okay.
At my place, power is gone.
No.
That's why there might be network issue. Now, if you want to delete this B node,
So you are sharing that drawing board. Huh?
I am sharing Paint.
Okay, I'm seeing only the notepad.
No. I have shared almost many apps. I'm sharing actually.
Oh, okay. Now I'm able to see.
Here, it's showing me that I'm sharing it.
Oh, I think maybe there is a delay there. That's
Okay. Now you're able to see the Paint untitled recovered
yes.
BMP. Okay. Now, if you want to delete this B node,
Okay.
if you want to delete this B node, you have a child D and E,
Yes.
right?
Yeah.
Now we'll check that whether D has any successors or E has any successors. So D is null. It is leaf node. E has H and I.
Okay.
So here in place of B, H will take the place of B now.
Okay.
Two childs if you want to delete a node with 2 childs, then you will be seeing the next successors, and the left side of that successor will be taking place of that particular node.
Okay.
Okay. So if you are deleting C, J will take the place of C. If you are deleting B, H will take place of B.
Okay.
Okay. So for that, I have not written full function here, but I'll just explain you with this. Now we are writing one delete function. After writing, we are just using an array, and thereafter we are inserting the elements into our node. Okay, and then we are deleting it. So here we want to delete some numbers. So here what we'll do is, first delete function will be seen now. Now first of all, if it is null, there is no tree is empty, there is nothing to delete.
Yeah.
Okay, next here we are taking some pointer variables which are of type struct node, parent, x and successor, x successor.
Okay.
Okay, so here parent, x and x successor, three pointer variables we are taking, and then parent and x we are initializing it with null.
Okay.
Now here we are writing one more function, search, which I will say you because I have not finished writing it, but okay, fine. Just to take that, like if a count is equal to false and true. Okay, so here false and true is nothing but we have taken two macros, true and false, dash define true as 1 and dash define false as 0.
Okay.
Okay, so here we are seeing that if found is equal to false, that means if we don't found the node which we are searching for, the element which we want to delete, then print not found.
Okay.
Okay, now if we found and if tree is not empty, that means this condition will fail. This if as well as this if. Now it will come to this if. Now in this case, what we are saying is that if you want to delete a node has 2 children. Okay, so this particular if condition is for 2 children. Okay, first we will see for null. Tree is empty is already done. If at all, if there is no node present, it will display. So first condition is fulfilled. Now a second condition where a node doesn't have child. That means right as well as left is free or null, right?
Okay.
It's a leaf node. It doesn't have children. So you will simply check that if x left is equal to null and if right is equal to null, then what to do? You will have to delete that particular node, and node doesn't have any child. So at this time, this condition will be true. Now, if parent of right is equal to x. Now what this means is, what we will be doing, the parent means the node which we want to delete. No, sorry, no, the parent is not, this is not the node, node, whatever node we want to delete, the parent of that node.
Okay.
We will have to see that if we open this paint and